Hello everyone, this is Mr. 13 Things, finally getting around to why it is so important to learn all the points on the unit circle, but essentially at least the first 45 degrees, said points being looking at a circle here. So this is the why and how often it comes up, and it's going to have to do with the concept of coordinate rotations, reflections, etc. Or what you might have learned way back through elementary school called they are called transformations. So what we're going to do is remember, we're going to know that we can get any point on the circle and then draw the inscribed box. That'll take us to a point here, and if that point is on the upside of 45 degrees, we can flip the values from the bottom 0 to 45. So there's a bunch of kind of geometrical playing going on, and then we quickly learn the angles from 0 to pi over 12 being rotation of 1 hour in time, pi over 6, pi over 4, having values of x and y, 1 and 0, square root of 6 plus the square root of 2 all over 4, square root of 6 minus the square root of 2 over 4, teaching the word conjugate and the sense that one is bigger than the other. X is bigger than y in this case. X is bigger than y, square root of 3 over 2 and 1/2, and x and y are both equal to each other in this case. Students may see this also as this 1 over the square root of 2. You can show them later why these are the same thing. So why we do this, we know that these are the cosines and these are the sines and these are the angles. Now, how often does this come up and how often are they used, and why the obsession with the unit circle? Essentially, I would say it's so that you can understand waves, but also that you can understand what's going on in your phone when it comes to, or what's going on in your game. And so what I'm going to basically show here is we're going to show what this looks like if we start talking about looking at points that are x and y. Can also be written in a format that looks like this, x and y. It's called a vector format. Though in reality, x and y and z is a little bit more relevant to today's world, looking like x, y, and z in a vector. And how do sines and cosines come into this? Well, if we have essentially a point in space right here, if this is 0, 0, and I want to rotate that point some angle theta, right? If I want to rotate that point some angle theta, all I've got to do is this. Write out that point, x and y this way, and then write a transformation matrix that looks like this. Cosine of theta minus the sine of theta, the sine of theta, and the cosine of theta. This is the most simple way to introduce it, though in reality what you really want to learn to get students to understand is that taking this from 2D to 3D is not bad at all, but just showing that this basic mathematics is what gets this to the point, right, x prime. So if this is x comma y, then this is x prime comma y prime. What happens when you rotate something an angle theta? They come up right here. Or if you think about the other thing we talked about, if you are going to be reflecting about some line, let's say 45 degrees, and you wanted to take a point right here and reflect it up to a point right there, mathematically, we all know how to do it with a mirror. It looks like this. Cosine of 2 theta sine of 2 theta, sine of 2 theta, and minus the cosine of 2 theta. If we take that matrix and multiply it by x, the xy vector, we get the reflection. So this is rotation, and this is reflection. Remember, of course, other concepts of translation and the like that we've done every year from 2nd grade on, but understanding how often cosines and sines come up is my only intent here. Eventually, you would like students, and I would think it's probably best to start that way, though it's very tough looking at their curriculum, except for the curriculum of what kids are doing on their phones, to realize that these patterns of cosine minus sine, sine cosine, or cosine 2 theta, sine 2 theta, sine 2 theta minus cosine 2 theta, end up showing up in many, many different ways in not a 2 by 2 matrix, but in a 4 by 4 matrix, and I'll talk about that right now. I'm going to kind of go ahead and erase this, edit, cut. This, of course, takes you into matrices, and matrices is the thing that makes spreadsheets work pretty nicely. But if we talk about now something in 3D space, having coordinates x, y, and z, which can be written x, y, and z. This single learning to kind of indoctrinate students that this is not the only way we talk about coordinates. We actually talk about coordinates that way more often than not when we get into computer graphics and the like. A vector, a column vector versus a row vector. That in 3D space you actually have 3 angles of rotation about the x, y, and z. That said, if you have a vector stacked up like this, x, y, z, and then later on you're going to see we're going to add the 1 here so we can take advantage of not a 3 by 3 but a 4 by 4 rotation and translation matrix, where you start with 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. This being the translation vector. In other words, something to move it, to translate this point or set of points. Doesn't have to be 1 point. And now if you want to do a rotation about any particular axis, you can play with just 4 of these. So we'll go back to what you just saw. I'll get rid of these, edit, cut. And if I want to rotate at an angle theta, I want to rotate theta, rotate the points by this angle theta. What I just do is I put in here the cosine of theta minus the sine of theta, the sine of theta, and the cosine of theta, and I multiply this matrix times that vector, and I will get the new points x prime, y prime, z prime, and always 1 there. And we can then also think about the inverse, the concept of inverse. If this matrix moved it a value theta in a positive direction, the inverse of that matrix will move it in the reverse. And so the concept of using transformations matrices applied to their phones. Because last time I checked, /iPods /computers. Last time I checked, most every student is dealing in 3D in some way, shape, or form. So learning to have them play around with this a little bit, if nothing else, at 15 degrees increments, so they start to understand the importance of understanding the cosine and the sine of values, both for reflection, and for rotation. Thanks for listening.